All right, we'll rewind here for a second. All right, let's just take a look at this. We're going to go over a couple different strategies, how to figure these out. It kind of gives it away here using conjugates. Do you know what a conjugate is? No? All right, we'll get to that in a second. First thing, though, let's take that right-hand side. Secant of x is 1 over cosine of x minus tangent of x, which is sine over cosine. Sine of x over cosine of x. All right, I can just consolidate that, right? What can I write that as? 1 minus sine of x over cosine of x. I can write that as 1 minus sine of x over cosine of x. Is that the same as the left-hand side? No, it's not even close. Okay, not even close at this point. I guess you got a sine and a cosine there, and you got a 1 somewhere, but it's not the same. All right, you're really stuck. There's nothing you can do really at this point. Now remember, you cannot, like on this left-hand side, we talked about it yesterday, you cannot split up a fraction that has a binomial in the denominator. You cannot take cosine of x over 1 plus sine of x and break that up as the cosine of x over 1 plus cosine x over sine of x. Absolutely cannot do that. All right, so that's not on the table. But make sure, well, come on now. But I kind of gave it away. I said use conjugates. And on that little sheet, what number is that? That is number 5. So if you take a look at that, it says in the expressions containing 1 plus sine of x, 1 minus sine of x, 1 plus cosine, anything with 2 binomials, it is often helpful to multiply both the numerator and denominator by the appropriate conjugate. Well, here's the deal. If you have, let me do it on the board. If you have 1 plus sine of x, its conjugate is 1 minus sine of x. It's just the same thing with the opposite sign. That's all it is. You've had conjugates with like complex numbers, like 2 plus 3i, 2 minus 3i. Same thing. So if you have sine of x minus cosine of x, its conjugate is sine of x plus cosine of x. All right, so now we at least have an understanding what the conjugate is. Now, I technically have 2. I got this one here, and I got this one. You're better off multiplying the denominator. 9 times out of 10, that's going to be the way. So start on that left-hand side. And I'm going to start with cosine of x over 1 plus sine of x. All right. And you got to multiply top and bottom because it has to be basically a factor of 1, so you don't change the value of the fraction. So I'm going to multiply this by 1 minus sine of x. Multiply it by 1 minus sine of x. Okay, got to multiply top and bottom by the same thing. All right, now I know I've been doing this a little bit longer, so I know a little bit more of the tricks here. But like that cosine of x, you could distribute that in. But since I kind of know something, I'm going to not distribute it until a little bit later. It's always okay to, but sometimes you got to factor it back out. So I'm just going to leave this top as cosine of x over 1 minus sine of x. I'm going to leave that top. All right, now what happens with the denominator? Here's why we do this. You basically have 2 binomials, 1's plus and 1 minus. When you FOIL them together, what do you end up with? Okay. When I FOIL those 2 together, 1 plus sine of x times 1 minus sine of x. I mean, if you go through the whole thing, you get 1 minus sine of x plus sine of x minus sine squared. And what happens to the minus and the plus in the middle? Adds up to 0. So I'm left with 1 minus sine squared of x. So I got 1 minus sine squared of x. All right, now there, and that leads to typically it's going to lead to one of your Pythagorean identities or a form of it. Well, that 1 minus sine squared is the same as what? Oh. Anytime you see that, you got to think Pythagorean identities. Like, and those of you who were here yesterday, you probably know what I'm talking about. Those of you who weren't may not. That's all right. You got to get your sleep. Understand. So 1 minus sine squared is the same as what? Cosine squared. Okay, cosine squared. I'm not picking on you, Emma and Lucas. I'm just bringing up. Remember, sine squared x plus cosine squared x equals 1. And anytime you get one of those by itself, you can use that Pythagorean identity. So cosine squared of x equals 1 minus sine squared. All right, so you can take out the sine, 1 minus sine squared, cosine of x, 1 minus sine of x over cosine squared. Okay, now, hopefully you can see why I didn't distribute that cosine of x in. Why didn't I distribute it in? Because what's going to happen now? Cancels. If you distribute in, you might miss that little piece there. If you do distribute in, you're going to have to factor it back out. But since I kind of knew what was going on, I saw it, looked over there, that cancels. I'm left with 1 minus sine of x over cosine of x, okay? All right, we got the same thing on each side? All right, this one's a little more complicated. You got a little more steps going on. You got to keep some things in order. You had to work on that right-hand side as well as the left-hand side. All right, so that's using conjugates. And you really got stuck. You really don't want to do that until you get to a point where you can't do anything else. I converted the sines and cosines. I did that. But now I said, all right, what happens if I do multiply by 1 minus sine of x? You are going to have to just take some chances and try things. They may or may not work. You're going to go down a wrong path. You got to figure it out and come back. All right, so that's using conjugates. Second thing that comes into play, factoring. Factoring never dies. All right, cosine to the fourth x minus sine to the fourth x equals 1 minus 2 sine squared. Well, what can you even factor out of that? Make sure you understand that. What can you even factor? The 1 on the left factors. The 1 on the left factors. What the heck is going on here? All right, let me just go backwards for a second. A squared minus b squared. Factors into what? A minus b times a plus b? Do we know this? You guys are staring at me. Okay. Hopefully you're just non-responsive and you really know what's going on. Hopefully you're not like, I have no idea what he's talking about. All right, a squared minus b squared is a minus b times a plus b. Well, I don't have a squared minus b squared, but a to the fourth minus b to the fourth is just another case of it. So what do I get there? That would be a squared minus b squared, a squared plus b squared. So we had the same thing, except instead of a and b, we got a cosine. So that factors, it's a difference of squares, into cosine squared x minus sine squared x times cosine squared x plus sine squared x. Look at the right-hand side. That's what I want to end up with. It's already in terms of sines and cosines. There's nothing we would want to convert at this point. What does... Come on. What does that equal? Cosine squared plus sine squared. Logan? 1. That's a nice big 1. That's nice. Okay, that's nice. So that whole thing's a 1, so you have this times a 1, so really you're just left with cosine squared x minus sine squared x. That's what we're left with. Not done because I got to make it match the other side. All right, so you tell me what do we got to do from here? What do we need to get rid of? How do I say that? What do I need to get rid of? Got to get rid of the cosine squared because you don't see a cosine squared on the other side, do you? Nope. So now cosine squared from our sheet, I'm going over that yesterday, cosine squared is the same thing as 1 minus sine squared x. So I can take the cosine squared x out. Hold on. That gives me 1 minus sine squared x minus sine squared x, and that gives me what? 1 minus 2 sine squared x. 1 minus 2 sine squared x. 1 minus 2 sine squared x. All right.
What do you do with the one that's up top?
This one, right there. Well, really, you can think of it like this. So it's that times 1, which should just leave you that. Okay. So I just didn't write it at that point. There we go. So we got that. All right, so that's factoring. All right, now this isn't an identity. I'm just saying to factor that. And this is just because you're going to come across some of this, and it's like you're not quite familiar with it just yet. So what does that look like if you would factor that? If you come across. So cosine squared theta plus 3 cosine theta plus 2. All right, just take a wild guess at it. You got this right now. Give you a clue, and everybody else. All right, give you a clue, and everybody else. This is the same. Think of this as x squared plus 3x plus 2. Okay, that's all it is. Except instead of x, what do we got? Cosine. Okay, same thing. What was x squared plus 3x plus 2 factor into? That factors into x plus 2 times x plus 1. All right, so this is what we got. Well, this is going to factor into cosine of theta plus 2. Cosine of theta plus 1. All right. So that's how you can have different cases of factoring here. You got a squared, you got a linear term, you got a constant. X squared plus 3x plus 2, exact same thing. Okay, you're using the exact same principles. Just want to make sure I hit that, covered that. All right. Now this one isn't the same as that one. That's going to come up at some other point. But last one I want to do together. Cotangent to the 4th x plus cotangent squared x equals cotangent squared x times cosecant squared x. Multiple ways you can attack this one, and sometimes sometimes there's like a really quick way, and sometimes there's a really long way. I'll give you one quick way. All right, clue. Take a GCF out of the left-hand side. Take a GCF out. What do they both have in common? You got cotangent to the 4th plus cotangent squared. That's no different than, y to the 4th plus y squared. You would take out a y squared, and you'd be left with y squared plus 1. So we're going to take out a cotangent squared. So cotangent squared x, and that's going to give me cotangent squared x plus 1. I would tell you at this point, what do you have that's similar on each side? I got a cotangent squared x. I got a cotangent squared x. I would look right now for a Pythagorean identity that contains that. And I would cross my fingers that there is one for them. Because we know 1 plus, if you look at your Pythagorean identity sheet, 1 plus cotangent squared equals what? Okay, so from your identity sheet, 1 plus cotangent squared x equals cosecant squared, that's a C. Cosecant squared x. So what do I just take that out and put in what? Yeah. Yep. So cotangent squared x times cosecant squared x. Okay? Done. So that one's really easy if you see the trick. If you don't, you start doing some different things, you convert to sines and cosines, which, we said is a strategy. You could end up being there for a while, but you could get it for now. All right, you need to do some on your own. Okay, classwork on these. Some of these are going to be like almost the same as ones we did in class, except maybe instead of sine is cosine. Some of them might be a little bit different. You got to start a little bit. This is new. So work together, help each other out. If you're totally lost, that's what I get paid. I help you. All right, let me stop this.
He's gonna go to his bed.